this example is, or this is going to be the conclusion to our example number 7, where we started off with y squared minus xy equals 3. And just kind of, we want to make sure that we understand how to finish off the second derivative. First derivative reviewing, we went to the product rule, and from the product rule, we simplified and solved for our first derivative, and we found that it's y over 2y minus x. And now for our second derivative, so our idea is to take this whole expression and take another derivative of it, is we're going to have to use the quotient rule. The top function is y, so our derivative is going to be 1 times by the derivative of y. So in other words, our derivative of y is dy dx, and that's actually intuitive because all the other questions we started off with, if you had y equals x squared, the first thing we said, the next step was dy dx equals 2x. So naturally, when you have a derivative of y, we should get dy dx. Our denominator, our g term, is 2y minus x. So the derivative of 2y minus x is going to be 2 times derivative of y is 1. And then chain rule says we have dy dx. And then sum and difference rule, the derivative of x is 1. So if we clean that up just a little bit, g prime is 2 dy dx minus 1. Next thing we want to do is just, again, write down what the quotient rule is. And it's f prime g minus f g prime all over g squared. Now we're just going to substitute and simplify. A good way to kind of go through a video example, and we probably should have said at the start, is to maybe play it through all at once and then kind of go back and stop it and pay attention to the things that we're doing in the example. F prime is dy dx. So our second derivative for our function is going to start off with f prime dy dx times by our denominator, our g function, which in this case is 2y minus x. And then we're going to subtract from this expression our f product, or our f function, which is just the value y. And so try and be consistent with our colors maybe. Let's go green, let's go y. And then our g prime is 2 dy dx minus 1. And our denominator is going to be 2y minus x squared. So we want to simplify this. We want to be able to get to just an expression for what the second derivative is, which means where we have our dy dx's, we have to go back to substituting what dy dx was earlier on in the question, and dy dx is y over 2y minus x. So every place we have dy dx, we are going to put in y over 2y minus x. That's a straight substitution for the derivative. So dy dx is that, and then we have 2y minus x, and we have minus our y value with 2 times y over 2y minus x minus 1. All over 2y minus x squared. What a mess. So now we got to figure out how do we want to simplify it. The fact that I have a fraction inside of the fractions, I would just like to multiply everything through probably by 2y minus x in the top and the bottom of the question, or factor 2y minus x out, or add fractions. I mean, there's lots of ways for us to kind of look at what we have, but at least in the top, let's recognize we have 2y minus x under some of our terms, but not under all of our terms. So let's clean things up just a little bit. So I'm not going to really change anything with the first part. I have 2y minus x, and I have 2y minus x over 1. And then the second part, if I multiply through by the y and kind of clean things up, on the first set of brackets, it's y times 2 times y. So this becomes 2y squared over 2y minus x. And then if I multiply through by the y, I have minus y, and it's over 1. There is no denominator with the minus 1 at the end. And I have 2y minus x squared. If I want to multiply the top and bottom or factor out 2y minus x, it's mathematically the same thing. But let's just kind of look at what happens if I take the whole expression in the top and times everything in here by 2y minus x, because it is my common denominator. It kind of looks like it's redundant in the first part because I know I've got the 2y minus x is happening here. But multiplying by this extra 2y minus x in the first term takes the fraction out. And then I use the distributive property. I'm going to multiply it through on the 2y minus x to cancel out that fraction at least. And distributive property tells me to multiply by the y by it as well. And whatever I do to the top, I have to do to the bottom as well. So to kind of keep things equal, times the top by 2y minus x times the bottom by 2y minus x. And let's simplify things. So what I'm really doing is getting the fraction out of the question to begin with. So mathematically, this 2y minus x and this 2y minus x cancel out when I do my first distributive property. And my top expression still has a y value, and it still has 2y minus x. Multiplying the 2y minus x through on the second set, those 2y minus x's cancel out this time, and I have 2y squared times 2y minus x. And I still have this actually in big brackets. I haven't taken those off. And then on the last set of the expression, this 2y minus x is going to multiply by the last y. I have y times 2y minus x. And that ends my big brackets. And in the denominator, I can put those together, and I have 2y minus x cubed. Let's just multiply things together, gather up our like terms, and simplify our equation as much as we can. So y times 2y, y times x, and then if I multiply through 2y squared times 2y, let's leave those in brackets, is 4y cubed, and 2y squared times by the x is minus 2xy squared. If we just write those in alphabetical order, multiplying at the end, I have minus 2y squared plus xy. And those are in my big brackets all over 2y minus x cubed. And we're going to finish this off by taking off some brackets and simplifying a whole lot more. 2y squared minus x minus 4y cubed plus 2xy squared plus 2y squared minus xy, and 2y minus x cubed. Crazy. Put things together that are the same, and then we are done. Let's not worry about the order right now. Let's just gather up like terms. So we have, looks like 4y squared minus 4y cubed, 2xy squared minus xy, and minus x. Probably not the proper order since we didn't go highest degree to lowest degree, but it's just what it is. And the denominator is 2y minus x cubed. Crazy. But that looks like it's the simplified version of our derivative. I promise I won't give you any questions that require this kind of craziness.